In our last video, we discussed what particles exist inside an atom. We also discussed how electrons exist within electron shields of that atom. This video, we're going to have a look at how the electrons exist within each individual shell. So we're going to have a look at the electron configuration for the first 20 elements of the periodic table. So let's begin. Before we get to know how we complete the electron shell configurations, let's first focus on getting some important information out of our two examples here of nitrogen and calcium. The first important thing that we need to work out is what the atomic number is for each atom. Now, nitrogen has an atomic number of 7. You might remember that that atomic number describes how many protons there are in that element. Over here in calcium, there are going to be 20 protons that exist. This is important for us in electronic configuration because when we're talking about an element that is balanced, the number of protons will equal the number of electrons. The second piece of information we need to collect from the periodic table is what period or row that these elements exist in. So for nitrogen, it exists in the period or row number 2. In calcium, it exists in period 4. This is helpful to us because it will determine how many shells that we're going to use when we're completing the electronic configuration. The third piece of information that's useful to us is the group number. Now, groups are the columns within our periodic table. Calcium here is in group 2. Now, this information helps tell us that calcium will have 2 little electrons on the most outer shell. Nitrogen you'll find is in group 15. Now, if we ignore the 1 that's in front, the group tells us that nitrogen is going to have 5 electrons on the most outside shell. So let's use this information now to complete the electronic configuration for both nitrogen and calcium. Now the first thing that you'll notice is I've used the period here on each atom to determine how many shells that I'll need to complete these diagrams. But before we actually go into completing each diagram, let's quickly discuss the maximum number of electrons that each shell can hold. Now the first shell, or the closest shell to the nucleus, can actually only hold a maximum of 2 electrons. The second shell, going further away from the nucleus, can hold a maximum of 8 electrons. Now the third shell here can hold more than 8 electrons, but we actually start filling the fourth shell up before we complete the third shell. So when we're completing the diagrams for the elements between 1 and 20, this third shell can only hold a maximum of 8 electrons. Now for the purposes of this video, we'll consider that this shell can only hold 8. But before we get into completing these diagrams, let's quickly discuss the maximum number of electrons that the first, second and third shells can hold. Now the first shell, or the shell that's closest to the nucleus, can hold a maximum of 2 electrons. The second shell can hold a maximum of 8 electrons. The third shell, for the purposes of this video, can hold a maximum of 8 electrons before we start completing the fourth shell. Now, when we get to bigger atoms, we actually can fit more than just the 8 electrons in the third shell. However, between the elements of 1 and 20, we start filling the fourth shell after 8 electrons have gone into the third shell. So let's begin by taking a look at nitrogen and where the electrons of nitrogen exist within these shells. Now you may remember the group number helps tell us how many electrons exist in the most outer shell. Now we know that there's only 2 shells, and if we ignore this 1, we also know from the group number that 5 electrons must be within the most outside shell. To put these on our diagram, we pretend that for the first 4 electrons, we're drawing a little square inside. So we put an electron here, an electron here, an electron here. So they're balanced far apart from each other. The 5th electron continues around our little square, but we put it next to it. If we had a 6th, it would go here, but we know that only 5 exist on the most outside shell. On the first shell, we know that a maximum of 2 electrons can exist there. So we put the first one on top, and the second one on the bottom. Now we can check to make sure that we've got the number of electrons that are needed. We do this by taking a look at the atomic number. The atomic number tells us that there are 7 protons, but at the moment this element is balanced. So that means that we should have 7 electrons in our diagram. Let's quickly count them. That's 1, 2, 3, 4, 5, 6, 7. So now we've completed our diagram for nitrogen. Calcium, we do the same process. We start by looking at the period number, which tells us that there are 1, 2, 3, 4 shells. And then we look at the group number to give us an indication of how many electrons exist on the most outside shell. Here we have 2 electrons, so we draw them in as far apart from each other as we can, like I've done here. Now we start just completing all these shells from the most inside. Our first shell can only hold 2 electrons, so we draw them in on top and on bottom like we did over here with nitrogen. Our second shell can hold 8 electrons. We once again start filling these out like we do with that square within our circle. Then we put the second one as pairs next to the first one that we drew in our diagram. The third shell, it's like the second shell. It can hold 8 for the purposes of this video. So we go around and we draw the electron pairs within the shell. We check our answer once again by having a look at the atomic number. Now we know the atomic number represents the number of protons within this element. We also know that calcium at the moment is balanced, so the number of protons equal the number of electrons. So here we should have 20 electrons in our diagram. So let's count them. We've got 1, 2 on the inside shell, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So that has completed the electron configuration diagram for calcium. Now we've completed this, let's take a look at how we record the electronic configurations to describe the number of electrons in each shell. To do this, we start with the most inside shell. So for nitrogen, it's here. And we count the number of electrons that exist within this shell. So nitrogen has 1, 2, so we put a 2 down to begin. In the second shell, we have 1, 2, 3, 4, 5. To say that we're describing the second shell, we put a comma here, and then we put the number of electrons that exist within the second shell. If there was a third shell, we would put another comma here, we'd count the number of electrons that exist in that shell, and would record it there. With calcium over here, we do the same process. We start with the first shell, count the number of electrons, so we've got 1, 2, we put it down. We then put a comma because there's a second shell. We count the number of electrons that exist in that shell. So there's 1, 2, 3, 4, 5, 6, 7, 8. And we put that just here. We then separate a comma because there's a third shell. Once again, we count the number of electrons in that shell. So we've got 1, 2, 3, 4, 5, 6, 7, 8. And we record that here. Finally, there is a fourth shell, so we put a comma again. We count the electrons. We have 1, we have 2. So we record that here. Now we've described the number of electrons that exist within our diagram that's known as the electron configuration. So let's quickly revise. The atomic number here tells us the number of protons that exist within our atom. Now the atoms that we're concentrating on at the moment we consider to be balanced. So that means the number of protons also equal the number of electrons within our atom. The period here, or the row on our periodic table, tells us the number of shells that exist within our atom. The group in our periodic table, which is the rows of our periodic table, helps tell us the number of electrons that exist on the most outside shell. If there is a 1 in front of it, we just ignore that 1. When we're constructing our electronic configuration diagrams, we use the group to place the atoms around the outside shell. We then completely fill up the inside shells. Now, the first shell can only hold 2 electrons. The second shell can only hold 8 electrons. The third shell can actually hold more than 8 electrons, but the fourth shell starts filling up before the third shell is completely full. So when we're completing diagrams for elements between 1 and 20, we consider the third shell to only hold a maximum of 8 electrons. Then for elements 19 and 20, those electrons start filling the fourth shell. Then we can also describe the electron configuration. We do this by counting the number of electrons exist in the first shell, record it, and then put a comma. Count the number of electrons in the second shell, record it, put a comma. Describe the number of electrons in the third shell, record it, put a comma. Then finally describe the number of electrons in the fourth shell, and then record it. If there are less shells, we just record to the number of shells that exist within our diagram. So what we've learnt here is a strategy that we can use to complete the electron configuration for our elements between 1 and 20.